Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 13 from the specimen paper of the Cambridge 0580 IGCSE new syllabus from 2025, which is a non-calculator paper. Question number 13 here is about transformations, and it says on the grid, draw the image of triangle A after a reflection in the line y equals x plus 2. So we're going to take this shaded triangle A and reflect in the line y equals x plus 2. So the first thing we need to know is how to draw the line y equals x plus 2. So if you want to draw the line y equals x plus 2, you should understand, of course, that it's a straight line in the form of y equals mx plus c. Now we can draw this in many ways. There's many ways to draw this line. One way of drawing the line is to choose points. For example, I can say, what's y when x equals 0? Like when x equals 0, y equals 2. So you can choose this point here. And for example, when x is equal to, say, 1, y is going to be 1 plus 2, which is 3. 1 and 3, you can then join those 2 points together and draw your line. You could also use the fact that this is the y-intercept. When it's y equals something x plus c, this is the y-intercept, means it goes through the point 0, 2. Okay, and that the gradient is 1 because it's 1x plus 2. So for every 1 it goes up, it goes 1 across. So you end up with the same 2 points. Or we could say when x equals 0, y equals 2, that's the y-intercept. And when y equals 0, x equals minus 2. Y equals 0, x is minus 2. That's the x-intercept. So it goes through this point and this point. In any case, whichever way you decide to do it, however you'd like to draw the line, you're going to end up with the same line, the line that goes through these same points that I mentioned, and you just carry on the line so that it takes up the whole axis, and you have your line drawn. Let me just make some space here. Okay, you don't really need to draw it across the whole axis here, to be honest, because we only need in this area over here, but it's a good idea to draw it. So here we have the line y equals x plus 2, and again, it's a good idea to label it. Okay, we got to reflect this shape in this line. Now, when you reflect a shape in a line, you have to understand that every point is the same distance away from that line on the other side of the line, but the line joining the point and its image is always at right angles. So this point here will be reflected to that point over there. And this point over here, if you think about a line joining that right angles, it's going to be 1.5 squares, so half of 1 square is going to be over here. And this point here, if you reflect in that line, you're going to have 1, 2, 3, 3 squares. So it has to be 3 squares on the other side, 1, 2, 3. So there are the 3 sides of our triangle. Join them together and we have our image. And there we have it. So that is, so that's the answer to part 1. So I'll just write here, part 1. Sometimes they tell you to label a certain letter, but in this case, I'll just put 1 there. That's the answer to A, part 1. Okay, that's the image of triangle A after reflection in the line y equals x plus 2. The second transformation, we've got to draw the image of triangle A after an enlargement by scale factor 3/2 with center 1, 0. So this is the center of enlargement, 1, 0. So this point will stay where it is because it's on the center of enlargement, won't change. Okay. As for this point, basically the distance from the center of enlargement is 2. If you multiply that by 3/2, it's going to now be 3. So it's going to end up over here, this point over here. Okay, so you got this point and this point. And here, this is 4. A distance from the center of enlargement of 3. 1, 2, 3. So 3 times 3/2 is going to be 9/2, which is 4.5. So it's going to be over 4.5 units away. 1, 2, 3, 4.5. So it's going to be at this point over here. Okay. So another way to deal with this, actually, a way that I like to use, in this case, it's a bit too easy for that, but basically, I like to use vectors. So I look at the center of enlargement and I see where each of the points are from the center of enlargement, and I multiply that by the scale factor. So let's look at this point here, which has how do you get from the center of enlargement to that point by vectors? Well, you go up 2 spaces. So that's going to be 0, 2. If you multiply that by the scale factor, it will tell you the image of that point. So 3 over 2 times 0, 2 is 0, 3. So that means we've got to go from the center of enlargement 3 spaces up, as we can see that we've done. And for this point here, this will be the scale factor times the vector taking you from the center of enlargement to that point. So it's going to be 1, 2, 3, 0. 3, 0. And if you multiply 3 over 2 by 3, 0, you end up with 9 over 2, which is 4.5, 0. So that means from the center enlargement to the new image, I've got to go 4.5 from the center enlargement. So from here, 1, 2, 3, 4.5. So you end up at 5.5. And then we join them together. And if you think about this one, how do you get from the center enlargement to this point? Well, you don't go anywhere, 0, 0. And of course, anything multiplied by 0, 0 will give you 0, 0. So you just stay where you are. So on the center enlargement, it stays where it is. So our image is going to look something like this. And there we have it. And that's the answer to part 2. Okay, so there's 1 and 2 done. Now it says for part B, it says describe fully the single transformation that maps A onto B. So we're going to map A onto B. Now, one of the things that we might have some issues with, I'm going to try and do this so that it doesn't. I'm going to draw a triangle that looks like A. Can I mess with it? 1 second. Yes, I can. Okay. So if I take this triangle and I want to know, is B a rotation of A? Sometimes you might not be sure. Then you can just take a tracing paper, trace A on the tracing paper and rotate that and see, does it look like B at any point? And it does. At this stage, it looks like B. Okay, so it's definitely going to be a rotation. It's not a reflection. It looks like B. Okay, so it's a rotation. We've just got to figure out what type of rotation it is. Okay, we've got to figure out. So we've already determined it's a rotation. So that's 1 mark. Okay, that's 1 mark. But we've got to give the center of rotation and the angle of rotation. Now, we can work out the angle of rotation just by looking at this, as we said before. It's starting off looking like this. And you rotate it to 90 degrees. Clockwise, it looks like that. So it's a 90 degrees clockwise rotation. Okay, so we can say rotation of 90 degrees and clockwise. So we're going to, from this, get 2 marks out of this so far. It's worth 3 marks. There's one thing missing, which is very important, and which is probably the thing that most people find difficult in this topic, is it's to find the center of rotation. Okay, the center of rotation. So we found out the angle of rotation, we found out that's rotation, we found out how, whether it's clockwise or anti-clockwise, here's clockwise. Now we're going to find the center. Now to find the center of rotation, what we need to do is, we need to imagine this thing rotating around and what point it would rotate around through. So you could use some tracing paper and try out different options. Okay. However, I mean, that would work. So for example, I mean, I can see very clearly that the origin is not going to be the center of rotation. Okay. Because if you rotate this part, it's going to end up over here. So it has to end up over there. Right. So the center of rotation is going to be somewhere further along this way. You can see how it's rotated. Now, one way of trying to figure out the center of rotation is to do the following. So this is a way without tracing paper, just to give you an idea of how to do it, how to think about it. Okay, so if I make a line joining a point and its image, like the right angle, joining with the right angle, the image and the object. And I do the same for another pair of points on the object of the image. So for example, I could consider this point here and this point here, joining them together. if I was to draw a line that is at right angles to this line, okay, at right angles to this line, and cutting it in half, it's called the perpendicular bisector. And for this line, the same thing, the perpendicular bisector, something like a line that goes something like this, halfway through these two. And here, halfway through these two would be a line that goes something like this. Okay, we can see that those two lines meet at this point. Okay, so that is going to be the center of rotation, and we can test it out by using tracing paper. And I have something prepared. Okay, so here we've got tracing paper, and it's like we trace the object on the tracing paper that we want to rotate. Okay, and I've done it in such a way that this is right in the center of the paper. So what you'd do, you'd have your tracing paper, you would trace the shape on the tracing paper, and you'd put your pencil on the point which you think is the center of rotation. So if we think this is the center of rotation, we put the pencil on this point, and then we rotate the object and see if it fits over the image. And if it does, then we know we've done the right thing, right? So we can see that it does. So we know that that must be the center of rotation. Okay, so how did we work out the center of rotation? First of all, if it wasn't so clear, what I did was I joined points with their corresponding points on the object in the image. So the right angle with the right angle, and then, you know, from the right angle to the shorter side, that point to that point. And then I looked at this line and looked exactly halfway along this line, and then I drew a line which was like perpendicular to it. It's called the perpendicular bisector. Okay, and I continued that on to the region where I thought the center of rotation would probably be. And I did that for the other pair of points. I joined those two corresponding points together, and exactly halfway through them, I drew a line that's like 90 degrees to it. And where those two perpendicular bisectors intersect will be the center of rotation. So then you can test that point and make sure. Okay, so that's how we worked out the center of rotation, which we should give as in terms of coordinates. So we're told here that the center of rotation is -2 and 1. So the center of rotation is -2 and 1. So here we're going to write with center -2 and 1. So here we have rotation, angle, direction, center, 4 points needed to get these 3 marks. Okay, so there we have answer to question number 13, which is all about transformations. Okay, so I hope that was clear. Now, other questions from this particular paper can be found in the playlist on the top right of the screen at the end of the video. The link at the bottom right of the screen will take you to the questions dealing with transformations from the new syllabus that I have been answering questions from. From the old syllabus of, where most of the questions will be relevant as well, transformations you'll find in that playlist over there. And you can subscribe to my channel by clicking on the link at the top. Thank you for watching, and see you soon.